Yes, you are welcome to this channel. This is Solomon at Solo for Math. Today we want to look at this topic, functions, that students like most but seems maybe tricky to most of them. Let's cover it today. Don't forget to subscribe. Alright, what is a function? We know just for starters, a function is any rule that associates an element in one set to some element in another set, as we are going to see. So that means we have two sets of elements. We have what we call the domain set. The domain set has elements, and we shall always associate those elements to X, and then it will always, when we get the domain set, the M is in the domain, and we feed it in the element, in the function given, like we shall have a function here, then it takes us to a set which we call the range, and the range is what we call maybe fx. Like after getting x, you feed it in the function, you get what we call the range. So that leads us to the notation. How do we write functions? So functions will normally be written in two notations. One is if you have fx equals to, for example, x squared minus 1. Okay, so like this is showing you that it is a function, but this function is defined by x squared minus 1, or they can write it as this f x to x squared minus 1. So it means the same thing, like when you get the x values and you feed it in this, then you get what we call the range. Okay, like this x leads to the range, which is x squared minus 1. The x are the values from the domain set, and then when you substitute them in this expression here, it gives you what we call the range. Okay, we may look at some examples here. Example, given a domain, if we have a domain set -3, 0, 3, can we find the range of these values? This is the domain. Now we want to get the range if the function is, let's look at a number of functions. Let me have maybe this. So when you're given a domain, you're always given a function, then you can always find the range. Okay, so what you do, get each of these values in the domain, substitute it in the function. So for example, these are values of x. We can draw something like this, and we include them in here: 3, -3, 0, 3, and then the values of 2x plus 3. So whatever we shall get corresponding, like when we get the value of x, for example, -3, and we feed it in this, what we get, we shall put it here. When we get the value of x for 0, now in this case 0, we feed it here. What we get, we shall put it here. When we get 3 and we feed it here, and the value we get, we put it here. This set is what we shall call the domain. So let's start. When x is -3, let me write here. when x is -3, then it means our function will be a function evaluated at -3, which is equal to -3 and put it in this, so it will be 2 times -3 plus a 3, which is -6 plus 3, giving you a -3. So meaning we have a 3 here. Sorry, -3. Do the same when x is 0. Then our range is get 2 times 0 plus a 3, which gives us, so this is our f0 is equal to a 3. When x is 3, what is our f of 3? Meaning where there is x, we put a 3 in this function here. So we have 2 times a 3 plus a 3, which is 6 plus a 3, giving you 9. So we have a 9 here. So meaning the range is -3. You write them in the order according to the order that was given. Like the value that corresponds to -3 is a -3. The value that corresponds to 0 is a 3. And the value that corresponds to 3 is a 9. So that is simply how we get the range given the domain and the function. Let's look at another example. Using the same range, let's change the function maybe. If we have our function as this, okay, so I can draw this represent my range, which is -3, 0, 3. Then this side, of course, I have my domain. Sorry for that. This is the domain and this is the range. Our range is 4 minus x. This is x. So let's find these values. So here, when our x is -3, which value do we get here? It is 4 minus x is -3, giving us a 7. So meaning we have a 7 here. When x is 0, what is our range? 4 minus x, but our x is 0, meaning we get a 4. This is a 4. Then 3, when x is 3, substitute here, we have 4 minus 3, which gives you a 1. So meaning this is a 1. So the range is 7, 4, 1 in that order. Alright, so that is it. Maybe looking at another example, given a domain, k equal to -1, 0, 1, 2, 3. Find the range of the function fx equals to x squared over 2. This is x squared over 2. So to get the range, we said get these values of the domain, feed them in the function. The value you get is part or is an element in the range. So we can start with when x is -1, we start with this value. What is our f -1? it is equal to, our fx was x squared over 2. So if our x is -1, then it means we shall have -1 squared over 2. And this one is a 1 over 2, which is a half. We know when you square negative, it becomes a positive. So look at x as 0, means we need f0, which is our range. And this one is equal to, when our x is 0, we have a 0 squared over 2. We are evaluating the function at these values of the range, at these elements of the range. So we are simply getting the values in the range and substitute them in this function where there is x. So this one gives us 0. When x is a 1, what is the f1? Substitute where there is x, 1 squared over 2, giving us a half. Check. When f is 2, substitute for x as 2, so we have 2 squared over 2, which is a 4 over 2, giving us a 2. Check the last one, f3, meaning we substitute where there is x, we put a 3, so we have 3 squared over a 2, which is 9 over 2. So meaning our range is a half in that order, 0, a half again, 2, 9 over 2. So someone will wonder, why are we having a half twice? It's because these two different components or elements of the domain have given us a half. So it doesn't matter. As long as you've substituted properly, that can happen. Alright, now if they don't ask you questions about the range or the domain, I can give a question like, if fx equals to 5x plus 1, find Roman numeral 1 f2, f of 2, Roman numeral 2, f negative 1, Roman numeral 3, f0, Roman numeral 4, x if f of x equals to 21, 5x if f of x is equal to 16. Alright, so this is another way how we can ask this question or questions about functions. So indirectly, they're not asking you to find the set or the range, but if they tell you to find fx, I mean f2, it means they want a value, a certain value or element in the range that corresponds to the value 2, which is in the domain. Okay, so what you do, like we've been doing before, let's start with 1. We want to get f2, but we know our fx is equal to 5x plus 1. So if they want f2, you can see here that where there is x in this function, we've put a 2. So we do the same on the right. Where there is x, put a 2. So it is not 5 to 52, no. If it is 5x, then it means 5 times x. So that's why I have multiplied here 5 times 2 plus 1, giving you 10 plus 1, which is 11. So meaning f of 2 is 11. The value of the range or the element in the range that was corresponding to 2 is 11. Example 2, f negative 1, we do the same. Our fx is this, so meaning where there is x, we put negative 1. So 5 times negative 1 plus 1. This is negative 5 plus 1, giving you negative 4. right, 3 f of 0. Okay, our fx we know is equal to 5x plus 1. So it's good if you can write this before so that you don't make a mistake. So if they want f of 0, then it means where there is x we put a 0. So we have 5 times 0 plus 1, which is 0 plus 1, giving you a 1. Now number 4 and 5, it is now asking for x given the function, the value of the function. So now it's like they have given us the range, the value in the range, so they want us to find the value that was in the domain corresponding to the value of 21 in the domain, in the range. So we do this, we do just substitution. For example, fx is equal to 5x plus 1. But now our fx is given as 21. If we're given fx as 21, we just substitute fx is 21. So on this side I've put 21. This remains 5x plus 1. Collect like terms. So when I bring 1 this side, it will be 21 minus 1 equals to 5x. And this will give you 20 equals to 5x. So if you want x, divide by 5, divide by 5. So x is equal to 4. We can do the same even for this. That is 5, where they've told us that our fx is equal to 16. So from our function, which is 5x plus 1, we know our fx as 16 equals to 5x plus 1. We want to find x, so we correct like terms, bring this one this side, so it will be 16 minus 1, which is 5x, giving you a 15 equals to 5x. Divide by 5, divide by 5, and x will be equal to a 3, because 15 divided by 5 is a 3, so meaning here our x is equal to 3. Alright, thank you for watching. Don't forget to subscribe and to comment, to like and to share this information. See you.